So good morning. I'm Fran, and Sergio, Armando, and I are going to explain you what serverless computing is. Okay, so one could think that a serverless application or a serverless service is something that just runs on a client and it's just like a desktop application or something, but it's really closer to the opposite of that. A serverless service or a serverless application is run on an instance of or a container provided by a cloud provider like Azure or Amazon Web Services or Google Cloud. I think Alibaba also provides cloud services. Anyway, some providers allow you to have like a free plan or a free trial, and you have like limited resources or limited a limited time, and then you'll have to pay if you want to use more resources or if you want to use it for longer. And a serverless service, wait, a serverless service is, as I said, created or instantiated, prepared, like download the dependencies, build the code you have to build, and all of that, and then it is executed on demand. So it usually is like a function. You give it an input, and it gives you an output. It could be used for other things, but that's mainly the main purpose of it. Then the instance goes to sleep or it gets destroyed. And if you want to execute it again, or if you want to get your output back, you'll have to run another execution or another instance. And some user cases you can find of this, as other people have shown previously, are like web applications. You could use it to host a video call or a video game server or something like that. It's very used in artificial intelligence for training and all of that, where you need to have very powerful computers, but you don't want to waste a lot of money buying a supercomputer just for one model. And it can be also used for databases like Firebase or MongoDB. Okay, and now Sergio.
Well, after this introduction by Fran, who explained us what is a serverless computing, now I'm going to show you some benefits of it. First, we have no infrastructure management. This means that developers can focus on the core business logic. With a serverless platform, you simply deploy your code and it runs with high availability. Secondly, we have dynamic stability. This means that the infrastructure dynamically scales up and down within seconds to match the demands of any workload. Thirdly, faster time to market. Serverless applications reduce the operations dependencies on each development cycle, increasing development teams' agility to deliver more functionality in less time. And finally, we have the more efficient use of resources. Shifting to serverless technologies helps organizations reduce and reallocate resources to accelerate the pace of innovation. As we see, we have very focused benefits, which are like the focus on developing code and the scalability. But now, as our teachers of software architecture say, every architectural decision has good but also bad points. In this case, serverless computing has some too. First, the long-running processes. Serverless infrastructures are designed to scale up and down in response to workload, as I said before. However, for workloads characterized by long-running processes, these advantages are no longer present and managing a traditional server environment might be simpler. Secondly, the vendor lock-in. For some companies, deeply integrating with the native managed services of cloud providers like AWS or others is a cause of material lock-in risks that need to be mitigated. Thirdly, we have the cold starts. Because serverless architectures scale up and down to zero, as I explained before, they also sometimes need to start up from scratch to serve a new request. For certain applications like a low latency financial application, this delay wouldn't be acceptable. And finally, monitoring and debugging. These tasks are challenging in any distributed system, and the move to both microservices and serverless architectures, or the combination of the two, has only exacerbated the complexity associated with managing these environments carefully. And now is the time of Armando.
Okay.
Armando, you're muted.
Yes, I was getting the control and everything. So now we have a provider, which may be Amazon, maybe Microsoft, whoever, that provides us with our service, our servers, etc. What do? We now have to deploy it. Do we just send the code there? Do we just send the whole 15 gigabytes of code every time we make an update? We don't, obviously, because that's mostly inefficient. It kind of works like GitHub. So I make a modification to my code and I push it to GitHub. In GitHub, I don't send my full project. I just send the modified files. Well, it kind of works like that now, where I just upload the code, the remote code is updated only with the changes, and now it works normally. The user requests the service, the container is started, and the service is executed. We have to note that the first execution usually takes longer because of many things. The first thing is that when I run something, I need to allocate the resources for that. And the server needs to know what resources they are going to need. Most times they have a chart, a data, something that says you're going to need this amount of gigabytes of RAM, this amount of hard drive storage, etc. But the first time we don't know. So it takes longer to analyze everything and run. And this happens with every update. Obviously, if you don't update something and you update a different part of the application that you're not going to use, it's not going to take longer because you're not going to need that. I think deployment is pretty much covered. So that's pretty much all for the presentation. And now I think Fran had ready the
Yes,
example.
Yeah, I made like a toy example of what you could do with cloud computing. Okay, so this is a Google Colab. That's one of the Google Cloud services. This is just like a toy, a proof of concept that takes a picture from this person doesn't exist, and it applies some motion from another video, and it tells it makes a WAV file, a audio file, to say whatever you want, and then it applies the audio file to a lip motion to lip sync both the video and the audio. I don't know if I explained myself correctly. The point is, you feed the service or the whatever you want to call this a picture and a text, and it makes a video of that person saying that text. And it's just as we said, you set up the application and then you run everything, or just run it as a batch script. I'm not going to show the full process because it would take like 10 minutes, but the good thing of this is that it uses a lot of memory and a lot of disk space that I don't have to have, because it's somewhere on Google service, on Google servers, and I can go do my business and later check if it works. And as a proof of concept, and now is where Labra is going to say the part where Labra is going to appear.
I don't think you're sharing the audio, but
The audio,
we
yeah.
get the
Oh.
gesture anyway.
Damn. Okay, he was saying just this text. I don't know where I have it. This. Anyway, yeah, you could use this to be the backend of your application and have like a mobile phone app, and just ask the backend to give you the video or something. I'm sure you've seen this used sometimes. But
Yes.
anyway, that's it.
Okay, nice. Okay, very nice. We are going to stop the recording.